So, hi, welcome to Leading Tech, the podcast for the tech-savvy C-suite, the tech-savvy C-levels. Hi, Ricardo. Nice having you on the podcast. You're a CTO of Elemento.
Hi, Felix. Thanks for having me.
It's great to have you on the podcast today. And I'm curious, as well as our listeners, who are you? What are you doing?
Okay. I like to define myself as an aeronautical engineer. And maybe I think the first thing to clarify there is that many engineers, especially coming from more mechanical trades, are not necessarily tech savvy. I consider myself a tech savvy aeronautical engineer. I've started programming when I was quite young, and I think that helped me a lot in my career. During my career, I worked for different European actors in the aerospace sector, going from research centers like the German Research Center or large companies just like Airbus. And now I'm the CTO of Elemental, a company that is looking at drones and how they can help solving logistics problems.
That's amazing. That's amazing. When I first heard of these things, I believe that was from Amazon and flying zeppelins and you know what. So that's a very futuristic area you're working in. How did you get there? Like, how did you get the idea from the background you had?
Yeah, I started with two other co-founders in this venture who had already performed a market study, seeing that there is a market for drones that can go really far with not so large payload. I think the canonical example for us is a farmer that is in a very hard to reach region, but has a highly valuable product. I would say that for Germany would be coffee or mangoes, things that are not so cheap, just like lettuce, but they are in hard to reach areas like in the middle of Africa. So, and they depend a lot on logistics. So they depend on the road infrastructure, they depend on ports, they depend on all the bureaucracy that goes from taking their goods from A to B. And we saw drones as an opportunity to bypass all that. And maybe even if it's a little bit more expensive to fly in the first time, the savings you have with not investing in infrastructure are probably going to be worth it.
Okay, that calculation makes sense. Interesting. So, okay, that's somehow from the market perspective. From a technology perspective, since when is this actually possible, or how far did you reach with your research and development?
Oh, right. That's a very good question because it's a part of the technology world where the evolution is so fast that we can see it with our own eyes. When I was a kid, I'm from Brazil, and there it was very, very hard for you to have a model airplane. Not only because it was not a popular sport in Brazil, but also because it was only possible to fly a model airplane that had an internal combustion engine. So the small internal combustion engines were very complicated and very expensive pieces of technology that now are a thing of the past. Why? Because electrical motors are so much more efficient and batteries are so much more energy dense that small drones, especially the recreational drones, they can fly with batteries now.
Yeah.
And we see this trend coming up now towards larger aircraft. Me myself, I have supported projects in Airbus going towards megawatt class engines, electrical engines. So you can see that this is like really going forward there. But there are some technology blockers that prevent us from going directly now to large transport aircraft that are electrical. Therefore, there is a niche. There's a niche that we can exploit with the largest drone you can build without going beyond what is feasible in the current technology.
Okay. How big is that drone that you're talking about?
Well, our first prototype, and that was a very, very nice story because we used a different way of developing it. So we try to go as fast as possible during the pandemic. So take that in mind. We developed that in 6 months, and it's a 10-meter long aircraft. So it's pretty big. Okay, it's a lighter than air craft, therefore things get bigger naturally. But doing all that during the pandemic in 6 months, I still think it was a pretty neat feat.
Interesting. 10 meters in like
In length,
length. And what width would that have? Like,
or about 2.5 meters. It's roughly the size of a shipping container, if you can imagine a shipping container.
yeah, I
That's
see.
it.
I see. Okay, then follow-up question. What what weight would you like to ship with that drone?
Well, you have to bear in mind that this drone was developed for developing the technology of
Okay.
controlling this kind of craft. So there, we made a lot of simplifications all over, including reducing the payload, so that we could have a cheap platform to fly and develop further. So there, we could carry only like 5 kilos of payload. Maybe if we could optimize that, we would go much, much further. But at the current time, it was mostly a learning tool.
Okay, I see. It really doesn't matter for now how much weight you can carry. That's just the technology, the motors that you were building, right?
Oh, not even the motors. I think the motors for such small aircraft have become have evolved in our lifetimes from science fiction to commoditized goods. You can go to AliExpress and get top of line motors that have very good performance at this size class. So that's how fast technology is evolving for drones right now.
All right, I see, and you see that that's a new field to me. I'm a software guy. It also evolves quickly, but then maybe you can give us an overview over what kind of technology components you would use, like besides the motors, or including the motors. What is relevant for this kind of technology?
Yeah, and that's the funny thing because we talk a lot about how the drone looks and how we integrate the different bricks like motors, batteries, and so on. But actually, what is really bringing the value there is the software,
Okay.
and it's not any kind of software. It's software that has to be extremely reliable. So for drones, I think we are still learning how to develop extremely reliable software, and it's a big journey. But for commercial aircraft or for other kinds of aircraft, we have very rigid processes to develop software, and that's really where the trade secrets are. Like we have a lot of trade secrets in the industry on how to make this kind of software reliable and how to develop it in a secure way. So I think that's a big catch there, and that's a big hook that links our both activities.
I see. I see. Okay, you would say the hardware part is easy?
That depends. For in my case, yes. In my
Okay.
case, it's just building a big RC aircraft. When you go to transport category aircraft, then we are talking about crazy technologies also for hardware. But still there, I would say it's half and half. What we usually say for a transport airplane is that 1/3 of the value is on the airframe, so basically the shell. 1/3 of the value is on the engines, and all the rest is on the computers there.
Okay, I see. Then yeah, my question would be what is the challenge developing software for an aero ship or like a hardware product, in this case airships?
No, not even airships, but I think for everything related to aviation. Uh, our tolerance to failure in aviation is very low. Maybe one story that kind of illustrates how our words are different. Uh, right before uh, right before starting recording the podcast, I had a huge problem with my internet connection because one component that I connected to my computer just destroyed the Wi-Fi connection. There was some interference there, and it stopped working. I don't think in aviation this would be an acceptable behavior for any kind of critical systems. You wouldn't say that, yeah, okay, let's stop flying in mid-air, and in 15 minutes it may come back. So the big challenge is how to make the expectations of society with regards to safety to be met by the software you're developing. So it's basically software that will never fail.
I see. I see. Um, we had actually quite a similar discussion with a good friend of mine, Marcel Donges, who made clear what kind of levels of digitization, automation, and systemic automation and security companies can reach, and that most companies reach maybe very like a certain level of automation, but not like a systemic, all fully automated system. And like none of the companies, or like very few companies in that areas you're working in, would reach this the last level of security and automation, and the least level, the least possibility of failure. But it comes with a price, right? It's the most expensive way to develop software or develop products in that area. How do you
Yeah, most definitely, and that's really funny to think that in some companies we are already thinking about fully integrated design, where one engineer recalculates something at the end of the engineering food chain, and then the whole product is adapted to that. While in aviation, this is a massive challenge for implementation, especially when it comes to software. I have one example that is probably going to be a little bit shocking for you. Probably you already heard about the Boeing 777. It's a big aircraft that most companies use to cross oceans. So this airplane runs its critical systems on very old processors. I even have a list here, but I think the one that you will probably recognize is the Intel 8486.
yeah
It's that and two other processors of this era run in software that is extremely rigid in development. What do I say when I say extremely rigid? Basically, that for critical software, you know at all times where in the register a given variable is. You have to know how the memory is mapped. You have to know exactly what's the behavior, for example, when you have an overflow of a variable. If you have an overflow, God forbid, we never know. So you have to know up to really the machine code how how this is going to behave, and this is how we kind of guarantee some of the security right now. Uh, the problem is to that is if you look at any kind of modern programming paradigm, if you look at object-oriented programming, I don't think this is compatible with this kind of philosophy. If you have concepts like abstraction, you completely break down this whole concept of mapping the memory. Like you don't if you lose strong typing, if you go like for dynamically typed languages,
yeah
you don't even, like the compiler doesn't even know what it's receiving, so it can be it's completely out of question for this kind of development. And it's crazy, like how we see aviation as a super advanced field, and sometimes it resources to very I would say, sticks and stones methods of programming and developing that are extremely expensive.
Wow. Okay, I see. That means, what kind of like programming languages would you use, and what kind of like approach, like tech stacks, would you use in that area?
There's a little bit of everything there, and now the industry is relying more and more on automatically generated code. So starting with a SCADA model, or maybe a Simulink model in MATLAB, this software can generate automatically machine code for a given target processor.
Mm-hmm.
The later case there is already for drones. You can already program a microcontroller to drive the drone directly from Simulink. The problem is not necessarily on the programming language, because you're free basically to do whatever you want with the programming language by rule. But the problem is how the whole organization of software development for avionics has to be structured.
Mm-hmm.
And that's where the rigidity comes from.
Okay. Do you have an example for us? Is there something like you would plan out, software components or entire projects like from the beginning, like the waterfall approach versus agile methodologies? Is that something that makes it different?
Yeah, that's exactly how it would like at first to a normal software development. If you start looking at avionics software development, it will look like a waterfall approach, and a crazy complicated waterfall approach where you start with high level requirements, go into low level requirements, up to the description of every individual component with the expected behavior for everything. So it goes to crazy level of details, and it doesn't allow for a lot of flexibility, because you can imagine that in all those cases, if anything has to be changed, you're impacting the whole tree of tasks. What's different from a normal waterfall approach is the requirement for certification. All the software that goes within in aircraft has to be certified, and it has to be certified by the national or international authorities that are overlooking aviation safety. The problem is that these authorities, they don't have the workforce to read every single line of code. So what they actually do is that they impose how your organization has to look like, so that your organization can guarantee that software is going to be developed in the right way. So there you have one side that is doing development, and another side that is completely separate, that is doing tests and quality control. You have a part of the organization that is only looking if all the procedures are being followed. So it comes to the situation that writing code becomes a very, very small part of what the organization is actually doing.
Okay. I know it only from, for example, ISO certifications for IT security in, for example, banking, right? That's where I know it from. Is that comparable, or are there like even more strict certifications to do?
I think it's comparable in the sense that ISO certifications and so on, what they are asking you is to have procedures for for a number of situations
Disaster
that they have to
recovery.
be documented,
Yeah.
exactly, like disaster recovery, or like so these procedures, they have to exist, they have to be documented, and they have to be followed. So that's where the similarity is. However, for aviation, there's also the notion of separation of different organizations. So for some cases, I would think it would be acceptable that someone doing development could also do testing, and not in aviation. So that's one of the founding principles that brings all the security and the safety aspects to aviation. Not security, which is it's another big problem.
Okay. Do you want to also touch on this?
Yes, I think that's a funny one because it also it's probably mind-boggling for anyone doing normal development. If you look at cryptography as it is right now, cryptography relies on very difficult mathematical problems that are difficult for a computer to solve. For example, factoring numbers. The problem is that the difficulty of problems evolves with time. As technology evolves, they can get more or less hard. So imagine if you had some kind of asymmetric key exchange with an aircraft that is running a 486 computer. What is complicated for this kind of computer can be trivial for the computing power that we have today. Therefore, the security philosophy of aviation cannot really rely on the same premises that we use in normal software development. It's impossible, for example, to do what you do on a Tesla, to have over-the-air updates, because there you expose the system to massive risks. And now I would say that most of software security in aviation is done by the concept of air separation. So basically, you cannot hack an airplane if you're in the airplane, because you have no physical access to the network. There's no way that you can physically access it. Or sometimes, and I think this goes a little bit with the different kinds of philosophy of security that we have seen over the decades. Sometimes it can be security by pure obfuscation, together with our separation, sure, but very old security paradigms.
Okay. Yeah. How far, or at what point do you have to consider all these requirements? You're in your situation, you're in a prototype phase right now. Yeah. So obviously, I see you would apply certain design principles when it comes to security, building up interfaces, and how to update, how to upgrade your software. But yeah, how much do you have to really think about these requirements already?
It's a very, very important thing for you to think from the beginning. And that's probably what makes the difference between drone companies and drone companies. Some of them, or even aviation companies, because with so many VCs around, there's a lot of capital that wants to invest in different ventures. So when you look at some people that have absolutely no aeronautical experience trying to build a new airplane, you should be careful about that, because the complexity that lies behind it is sometimes mind-boggling. So for our case with drones, the problem that we are having right now is that all the certification standards are pretty new, and they are sometimes conceptual. They are based on the concept that the society accepts different kinds of accidents with different kinds of drones. Imagine if you have a 50-gram DJI that is flying with one camera there, and it just falls to the ground. Probably there you would consider this a pretty common situation, and you wouldn't even care if you're not the owner of this drone. Which is a very different situation from a drone carrying a 2-ton parcel. Imagine if it falls on top of a building, it can completely destroy the building. So the new regulation is coming in a way that is trying to adapt the strictness of the regulations according to the potential impact of the different kinds of drones. This is great. I think this is one of the most evolved regulations we have ever seen in aviation.
Mm-hmm.
The problem is how to transform this kind of concept in actual requirements, and then requirements to an actual development. What we are doing right now is we are trying to incorporate in the design of drones mitigation mechanisms for accidents or for unforeseen events. For example, if you look at Zipline is a company doing logistics for small parcels, mostly for blood samples in Africa. And what they do is that they use a deployable parachute both for landing and for emergency situations.
Mm-hmm.
And this is their way to prove to the authorities that they're not going to harm anyone on ground because they arrive at pretty low speed.
Mm-hmm.
So this is one way of tackling it. The other way of tackling it is the usual development that we do in aviation. Is just say, okay, my system relies on system X, so system X is never gonna fail, and I'm gonna over engineer it to death, so that's never gonna fail. Sometimes it may be necessary for drones, like larger drones like Lilium that is going to carry people.
Mm-hmm.
I think there will be systems that are going to be developed on this almost never gonna fail philosophy.
Yeah.
But if smaller drone companies ever go this path, the whole drone story becomes not economical anymore.
Mm-hmm. Yeah, you just mentioned Lilium. I haven't heard from them for a while. Are they still like actively working on like actual civil or people transportation?
They are. They are already performing test flights of their complete system. And yes, they will probably start the certification process very soon, where they will have to prove with tests and the documentation of all those tests that their vehicle is safe and reliable enough to start transporting people.
Interesting. Wow. So, what is your vision for your like more carrier focused drone?
I think all this kind of niches that don't require people to be in a flying machine, they are something to be explored, both for economical reasons, because I believe there is an economical market there for some applications, but also for new kinds of development. Given that the risk is already mitigated, that you're not taking people, you're not necessarily flying over densely populated areas. Maybe that's where companies can explore a little bit other development processes, just like agile instead of pure waterfall.
Okay, cool, interesting. And for your project itself, where shall that lead to? What is your goal?
So our goal is to actually bring a logistics drone to the market. This is based on lighter than air technologies, and right now we are figuring out whether we should pivot or we should continue on that technology pathway.
Interesting. So the technology that you've built so far, for whom would that be interesting?
That's mostly for either clients that are dealing with difficulties with infrastructure, or the military, or even infrastructure builders, because they're by definition they don't have the already deployed infrastructure.
Okay, I see. Maybe asking another more technical question, or you tell me what kind of let's say specific we talked about specific requirements on security and safety for users. What are the, let's say, technological specialties you're working with that are maybe quite rare, quite exciting to work with?
That's interesting because when you look at the technology itself, it's technology that doesn't look very innovative just by naming it.
Mm-hmm.
It's basically embedded systems. So it will look like automation that the big players in Germany are already doing. Like if you see the Siemens and the Bosch, they are already like doing automation and programming microcontrollers and so on. But when it comes to making it aviation or even aerospace hardened, then there is a whole new world of possibilities. One example, just to show you like how crazy it can be,
Yeah.
is that there is a phenomenon that happens in space that creates short circuits on the PCBs. Actually, due to the pressure and the vacuum and so on, the small solder points they start making small hair.
Okay.
It's really funny when you see the pictures. You see that shiny dot there, and
Yeah.
suddenly you start seeing like very thin hair made of tin, made of solder, going out. It's just like the solder reorganizing,
Yeah.
and eventually they make bridges towards the others, and your electronics stop working.
Oh.
Another issue that happens as well in space is that you have a lot of radiation coming in. So space hardening, the same microcontroller that you have here controlling, I don't know, like your lights, is a big challenge. So when you talk about the technology domains in aerospace, always be a little bit careful because you say, "Oh no, but I've seen this." Yes, you've probably seen this, but then it's 10 times the complexity because of all this phenomena we don't really hear about in our normal lives.
I see. I see. That's incredible. Now you're talking about space. Even reminds me of the Elon Musk's vision to to go to Mars and everything.
Hmm.
It's crazy interesting. Wow.
Yeah, which is something to be questioned. Like going to Mars, especially like in the timelines that he has been proposing, is something that we should ask ourselves whether it would be feasible or not. Then again, if you look at Elon Musk, that's a guy who has been working on different areas, and he eventually ended up in aerospace. As I said, very good. It's always good that there is investment there, but you should be careful because the challengers they always come very in very many times and in very expensive ways.
That's true. Yeah, but we'll see. I keep researching and testing. Um, let's see. Just like you said, if nobody was doing it, we would not have any progress. So just like you're doing it with the drone transportation systems.
Yes.
Amazing. No, yeah, I really like the talk. Being more technical, also being in an area that is quite kind of a closed system, also closed industry for many of us because we don't have so much touch points. Yeah, is there any like tech tip you can like tech recommendation or um, yeah tip in German you can give others when developing in this area or things that you might have seen you can do better?
Uh, maybe let's make it twofold. Uh, if it's people in other areas, I would, especially like in other areas related to aerospace or mechanical engineering or any kinds of engineering, is learn how to program. Programming is something that is very useful, and it also helps you to understand how machines work and tell you what is bullshit and what is not bullshit when you're looking at the current news. So that's one side of it. And maybe on the other side, when you look at from the tech world towards the aerospace world, is always think that it can be a little bit more difficult because, yeah, there's always unforeseen things in this world. So it's not as easy as it sounds.
Yeah, I can maybe add to this. I now, like during our talk, I recognize how difficult it must be also for regulators, for our lawmakers, to keep up with all these different areas of research and technology that evolve so quickly. We've seen it in life sciences or also banking, financial services, and then also aerospace. There are so many fields that regulators have to keep up and keep up to speed. Interesting, and that obviously being a challenge for product developers as well. But it's a huge challenge for the regulator too.
And that's something that is like a bad loop, a bad dependency loop that you create there.
Yeah.
Because if technology is advancing so fast and you want full oversight of the regulators, then you need the manpower to be increasing forever. So probably that's a good example to take out from the aerospace world, is where the regulators don't claim to know everything, but they at least try to create methods that companies can follow, and by following this they can guarantee or like ensure that the necessary outcome is being produced.
Yeah, very, very useful thought. I totally agree. Yeah, just a little bit like with the ISO certifications, right?
Yeah, exactly.
Putting up processes and procedures, yeah, that help meeting these requirements. Cool. Then yeah, like wrapping it up, Ricardo, it's been a very interesting talk. Maybe two questions. One is how do I reach you, or how do our listeners reach you? How do we contact you? And do you have maybe a recommendation, a guest that you see as an interesting guest for our format?
Yeah, I think that the best way to keep in touch is definitely via LinkedIn. That's where you can see the advancement of our project and also contact me if you want to discuss more. And I think the best guest you could invite is from a completely different area, but it has also a very compelling story. That's Raphael from curiosity.ai. Basically, what they are doing is developing a search engine for companies so that they can locate their own data. What is actually interesting about this whole story is that this guy is also an aeronautical engineer who converted himself to a software developer. So probably that would be a nice path for you to discuss.
Sounds great. Awesome. Then thanks, Ricardo. We'll link your social links also in the video. It's been a pleasure talking to you on this podcast, and hope to see more about flying goods and logistics with drones.
So thank you very much for having me, Felix, and thanks to our listeners.
Great. As always, final words. We're also on all the usual podcast platforms. So you'll find Leading Tech on Apple Podcasts, on Spotify, and with the video on YouTube, as well as on our LinkedIn channels of DVC Digital Venture Consultants. Thanks for listening.